For this last one, I need to show you a graph of y equals the square root of x, so like the parent radical function, except with a bunch of added characteristics. So for the added characteristics, I'm required to show you a vertical translation upwards, a horizontal translation to the right, and a vertical stretch of a factor that's greater than 1. So I chose 2 for that one. So this is like the original equation of a radical function with like all the characteristics. On my notes, a wasn't in there, but on other functions that I've seen, a kind of symbolizes like a slope, which I put it in there, and hopefully that doesn't offend anybody. So I'm just going to use that as like a slope here, or in this case, a vertical stretch. So vertical translations of a radical function are always like the k at the end of the equation. So if you wanted to go up, then you would do +1, +2, +3, whatever you wanted. I chose +4. But if you wanted to go down, then you would have to switch it to like a negative, -1, -2, -3. For a horizontal translation, which is always going to be the h, but you have to keep in mind the negative h, because even though it says that it's negative, that means that it's going to the right still, technically. So because I need to show you a horizontal translation to the right, I'm using -3. But because the negative is part of the original equation, then it's just kind of like a +3 that I plugged in, which means that it's going to the right 3. And for the stretch, I chose 2. The vertical stretch just means that the graph of this function is going to be kind of like pulled upwards and stretched out, but all that really changes is like the slope of it. So here's the new equation with all the characteristics plugged in. Y equals 2 times the square root of x minus 3 plus 4. So here's the graph of that. Y equals 2 times the square root of x minus 3 plus 4. And I put the original equation in here too, so I can show you like the changes and like what the different characteristics are coming from. So to begin with, you always want to kind of find the vertex first. So the vertex of this is going to be between the vertical translation and the horizontal translation, which means you want to look at the +4 and the 3. So the +4 means you're going to go up 4 because it's vertical, which means like up or down. So you're going to go up 4, and then the -3, like I said, the negative is like part of the original equation, so you don't really want to include that. You can't, or it's wrong. So it's just a 3, which means you go to the right 3. And then from there we have our vertex, which isn't really like a vertex because it's just like a straight line, but it's like the beginning point of this line for our new equation. And then for the 2, which is kind of like our slope, looking at this graph, so for a normal radical function, so like y equals the square root of x, the parent function, you would go up 1 and over 1, and then from the beginning point, you would go up 2 and over 4. So for this, you're doubling how far you go up. So just to show you what I mean. Because the stretch is 2, you're doubling the rise, but you leave the run the same. So it's still going to go over 1, it's still going to go over 4, but we're changing the rise. So if we double the rise, then it's going to be 2 to begin with. So we're going to go up 2 from the beginning point, up 2, and then over 1, and that gives us that point of the line. And then for our next point, we're starting back at the beginning, and we're going up 4, and then over 4 still, as we would with like the parent function. So once we have those 3 points, which are, you can find more points, I'm pretty sure, but that's all we really need to draw this thing out. So we just start from here, and then we follow, like we make like a curve, even though technically looking at it, if you just connect the dots, it would be a line, but you want to curve it and then follow it and show that it'll still be increasing on the x and y values. So it'll keep going up and onwards.